Year 2026, month of July. I normally don't upload videos in the middle of the week like this, but there were a few events that have happened recently that I wanted to make sure I got some opinions out about. We're not going to be going over any COBOL code in this video. This is more of a current events type of review. Alright, let's take a look here. Energy, AI rewrites, and the programmer of the future, what could finally crack COBOL code bases. We all know there's billions of lines of COBOL out there. It's getting difficult to maintain, difficult to kind of have the workforce that can go in there, understand systems, and then fix them, either refactor them or migrate them to modern programming languages like Java or C Sharp. But some things have changed just this year that make it look like COBOL could have an easier time with migration and refactoring. Let's take a look. All right. Uh, Energy and AI data centers. Oil is volatile right now because of the Iran war, and that's still we're not sure when that is really going to end, quote unquote, and what the recovery is going to look like. But because of the surges in oil prices, the North American production is getting a lot of research and development done. So true peak oil has been delayed again. I am pretty sure every refinery that's been blown up in Iran and the Middle East and Russia in the Ukraine-Russian war is going to get rebuilt. These wars will end, and it'll be a big boom to the oil industry and the industrial construction industry when that event happens. And it'll appear for a while that we've gone back to normal. Renewables are the majority of new energy investment, but they're not the majority of the whole energy pie. Okay, it is still an oil and natural gas world. I'd love to be proven wrong about that, but it's going to take more research and development to truly make a green, renewable cycle of energy that can actually feed industry uh, in the world. Data center growth continues with some environmental caveats. Some U.S. states have banned them. They are consuming a lot of energy on North American grids, and uh, there's going to have to be a lot of just new stuff added to the grids to deal with the problems that come with this. So there is plenty of work to do, but I hope will it actually get done? Will it be funded properly? Will it be reliable? We have to wait and see. Um, Also, in a related note to this, so you may have heard Elon Musk had the trillionaire status for like a week. All that really meant was the stocks of all of his companies, their value went up, and added all together it was $1 trillion. Really, it just means he had the collateral to get into debt for $1 trillion. I would, and he might actually get into that much debt, like maybe $750 billion to get a new 2 nanometer chip factory and memory fabrication building all in one up and running in Central Texas in the San Antonio Austin metro area. That would be really cool if that did happen. Right in my backyard, we would actually have the factory, the super factory that's going to be producing the chips and memory that can bring the cost of memory back down while we're going through this whole AI Humpty Dumpty. But we'll have to wait and see on that. So, AI accomplishments. AI rewrites Bun from Zig to Rust. Okay, so Bun was a replacement for Node.js and related ecosystems. It was a JavaScript runtime and had these other, development tools. Bun is now owned by Anthropic. Excuse me, I need to spell that right. Who make Claude, which is generally considered the best code producing AI at this time. AI has proven new mathematical theorems. AI recently disproved the Jacobian conjecture. I would like to point out that that does not make mathematicians obsolete at all. It makes them just as valuable because the AI is just, you know, outputting text, and it still requires a human professional who can look at that stuff and think about it and see if the proof really holds. The AI itself is participating in peer review, and humans are absolutely part of that process. So, mathematician is still a valuable scientist, of course. But this big, okay, I'm about to talk about the rewrite. So AI is proving and disproving math theorems. Bun was bought by Claude. Google Anti-Gravity is this really, really cool prompt-based IDE I think you should all try out, but be careful with it, okay? They're gathering a lot of data, but with just a couple of prompts, it was making whole projects right there on my local hard drive that are functioning graphics and everything applications. You ask it for a notes app, it'll make a notes app. I asked it for a COBOL analyzer, and I had this full, web browser based, very nice CSS analyzer just up and running in a few minutes. This stuff is it. Not only is the AI comprehending what I want it to make, it's typing it up really, really fast. And just how a fast typer is going to be better than a slow typer, if you don't have AI augmentation in your workflow, you're probably going to be slowed down. I think AI and human developers, these are going to go together. They're going to have to go together. Okay, so I would highly recommend getting used to something like Google Anti-Gravity. It makes VS Code look like just uh, like a sloth. Like really, you got to try it out. So you have all these advancements in AI, and Bun had millions of lines of Zig and something like the AI agents of Claude and Google Anti-Gravity. Within half a month, they rewrote the whole code base from Zig to Rust. This still required human developers to test everything and to make some fine-tune adjustments, but it worked. And now Bun is in Rust, and it's a Rust project instead of a Zig project. And so AI as a rewriter for code bases that can go from one language to another, that's enormous, an enormous accomplishment. And so if you're thinking, well, I'm thinking that could come to COBOL. We've seen a little bit of it. I know some people who have been working on various things that it's mostly they focus on COBOL refactoring COBOL to COBOL. But if you go COBOL to Java or go COBOL to C Sharp or Rust or Go or whatever, you're just not going to go back to COBOL. And so this is how those billions of lines of old COBOL might finally be replaced once and for all, is with this wave of AI powered rewrites. Okay, so the AI bubble. It's not quite, in my opinion, but it is a stabilization. Theorem proofs and disproofs are a killer application of AI. Program rewriters are killer apps. So just these two things alone, not the, stupid fruit cartoon videos. That stuff is kind of stupid, but theorem proof and disproof and program rewriters, these are killer apps. This is what AI is really going to be all about, and these are going to be implemented one way or another. Whether it's the traditional, energy hungry data center, or maybe like a very prestigious data center that you pay extra to subscribe to, that does everything more cleanly, all that. But this is one of the best applications for AI. That's kind of a meta use. Is it going to diagnose disease, discover cures and stuff? Yes. I think something like that's going to happen. Uh, and that is what is going to give AI its real value. All right. So programmers of the future. Okay. Once again, we're putting the science back in computer science, and we're going to be white collar managers of several AI agents. And we're going to be, working on our own, but that's always going to be a part of our workflow now. Analysis of variation, understanding systems a priori, which is reasoning. There is still absolutely value in a human being who understands a programming language in and out, can look at some code and say, this is what it does. That's always going to be needed. And then the a posteriori, the experimental kind of knowledge you get. So, test driven development, if you haven't been doing it, you'd better get in gear because it is back and it is more crucial than ever. TDD. You want your red lights, you want your green lights, and you want to know how to manually make a test because that's what the AI agents are going to be writing and rewriting for you to see that they are passing tests. And so it's going to be um, developing to the test. That's how you can kind of get an AI to narrow down what it's doing. So, stuff like the C4 model, which is new. I'll go over that in a moment. UML, you probably know that. Planning and architecture will help you navigate with changing technologies. Every language, every database can change. But if you understand the modeling, you understand architecture, you can keep reinventing an app like the Ship of Theseus. Everything can change, but it does the same thing. Here's my suggested reading. Okay. The C4 model book, it just came out. It was made by the creator of the C4 model itself. There were other books about it, but this is from the creator. It came out today, like July 21st, when I'm speaking to you now. And so that's a brand new, fresh book, and it will explain a more generalized model called the C4 model. It can go from these four models. That's what the C and 4 stuff means. And it helps you go from the big picture to fine details, all in one model, where UML was kind of like this kind of flat understanding. And UML, it had like so many different diagrams, and you couldn't understand the flow of a program well from just way too many diagrams like that. So the C4 model is simplified, yet it contains just as much information. It's not losing information. Um, so I am glad to see some innovation in that. These other two books written by the same guy with over 50, I think at this point over 60 years experience maybe, if of coding. This guy went from the key punches, the punch cards. He actually started with COBOL and then um, went all the way to enterprise Java and the modern stuff. So Clean Code is the book he's most famous for. It's now in the second edition. So between the first and second, I would suggest the second. It's a little bit more up to date with modern sensibilities. And then Clean Architecture is actually probably my favorite of his books. And that tells you about structure and design without going too much into the various languages and code paradigms. It just kind of tells you how to think more generally about what a program does so that you can just rewrite it in whatever language you have, whatever your agents know, and so forth. All right. And then at the bottom, don't forget the simple mathematics at the bottom. All right. You describe a problem with discrete math. Make the math go fast. If you can understand programs this way, with the stuff that you read about in a pretty simple book like Discrete Math, and then you model it with this, then you can get your AI agents in Google Anti-Gravity to make you a big rewrite. And that is going to be the value of the future programmer. And it may not just be for COBOL, it could be all kinds of languages going old to new. I've briefly mentioned MUMPS, the healthcare tree-based database. That's going to be a hoot if we ever get to rewriting stuff in that. And there's still a lot of old PHP, but then again, PHP is still a living language. Ruby, it's kind of it's also still living, but I don't know if people really go for Ruby over like a basic React app these days. Um, but there is a role for Ruby and PHP because they are server-side HTML embedded systems rather than just JavaScript systems. So there's a role for that approach. But we'll have to see, what the population of websites out there is they're asking for in the future. Okay, but that was sort of my big 2 cents about current events in uh, the programming world and how it relates to the future of COBOL. Thank you.